My name is Andy McLean. I'm part of the automotive team at Analog Devices. And again, what I would like to talk to you today is about realizing an immersive cabin experience. So this will be very familiar to you. I think we've seen probably about 6 different versions of this slide throughout the day. But really, I wanted to start by saying we really are in the midst of the biggest revolution that I think the automotive industry has ever seen, ever. This is really large. The 4 things that I show on the screen here, if any one of these was happening, it would be very disruptive. But with all 4 of these trends, or megatrends, happening in parallel, this really means we have to rethink the automobile. So, starting in the bottom right here, again, we've heard about autonomous vehicles, we've heard about autonomous driving. For those of us that have been around for a while, we've been talking about this for a very long time. So even though we haven't reached this sort of predominance of level 4 or level 5 driving experiences, I think it's fair to say that even as far as we've got with L2 and L3 systems, this has led to a fairly disruptive impact on automobiles and automobile architectures. The last couple of presentations focus very much on the electrification side. And whilst this is very disruptive or innovative in terms of the powertrain, what it also means is it's been an opportunity to really, rethink the architecture of the vehicle. So the impact of electrification has been well beyond its primary goal in terms of sustainability and changing the powertrain of the vehicle. And then another trend is in this connectivity space, and I'll talk a little bit more about this later. This is in terms of the wiring inside the vehicle, which in itself is very significant. But in the context of the cabin experience, we're now seeing 5G and wireless systems lead to an entirely different user experience in the vehicle. So again, I'll talk a little bit about that. And then, of course, last but not least, it is the software-defined vehicle itself. So the whole reason that we have a software-defined vehicle is really associated with this user experience and with the change in the cabin experience. So that all sounds great, but obviously we wouldn't be here if it didn't come with some challenges. So that's what I would like to talk about now, is just kind of tee up some of the things that are going to have to be overcome, are going to have to develop in order to realize the vision associated with the megatrends that I just introduced. So the first one might sound very simple, but I think it's actually the most powerful one, which is when we look today at why people buy vehicles, it really is more about that user experience. It's not so much about the traditional elements such as top speed or acceleration or brand loyalty. I'll show you some statistics on the next slide that actually highlight why people buy vehicles today. In terms of challenges, again, I've talked about the architectural changes. You guys have seen that in some of the presentations earlier today also. What this means is, with the shift in the architectures towards zonal, we really need advances in all elements. We need advances in processing, in particular in edge processing. Something that is not talked about as much is the change in connectivity technologies that are required in the vehicle in order to execute this shift to zonal architectures. And then, of course, the software itself, very much a part of the software-defined vehicle. Another challenge, we talked about the software. That's one element, but overall, that's really an example of how, or the realization of new applications, new algorithms that are being introduced into the vehicle. So in general, we talk about this increase in the digitization in the vehicle. And again, I'll show some examples of new applications that are driving this shift in the user experience. The other thing, and again, we've heard this highlighted a little bit today, is at the end of the day, we're all part of a business. And there's a very significant shift going on in terms of business models and how the various supply chain is being rethought, and how the money exchanges hands all the way from the user through the OEMs to the suppliers. So this is another challenge. How does that all settle down? I think everyone has a view that they own the new money, which is obviously not the case. It's really going to be a redistribution. So the bottom line is there's many more, but just these three things alone really represent this disruption or this significant inflection point in the industry. And therefore, the way I look at it is this is an opportunity. So let's talk a little bit again about the cabin experience. This is really about the user experience, to give it a more general name, but we're talking about the experience that you have in the vehicle and as part of the mobility experience or the transportation experience. So I think the implications of electrification and autonomy on this are very, very clear. But let's unpack the trends a little bit in the context of that user experience. What do we really mean by cabin experience, and what are those technical implications? However, I mentioned earlier, just to make this real, this isn't something that we're just making up here. There was a couple of recent studies showing a couple of data points here that essentially say this user experience is why people buy cars. So 70% of millennials cite technology basically as the reason why they will buy one vehicle over another. Again, it's not so much brand loyalty, it's not even the shape of the car, all the things that were traditionally true. Now it's about that technical experience, that technology that drives the user experience inside the vehicle. And just to reinforce that, there's another data point here of the top 10 things, top 10 reasons that why people buy cars. 5 of those top 10 are associated with infotainment or ADAS. So really reinforcing that this user experience that consumers are looking for is very important to why they buy cars. And at Analog Devices, we define this user experience as being immersive, connected, and personalized, which is what I would like to talk a little bit more on the coming material. And just to broaden out the discussion a little bit more, so user experience is one thing, but again, people, when they're making purchasing decisions now, are looking at many different factors. The first one, we've heard about the technical implications of electrification. This is very real. People want a vehicle that is environmentally responsible. That's just a very key element. I've talked about the user experience in terms of being immersive. This would traditionally be the sound system or the infotainment system that you have in your vehicle. But also, you may not want that all-encompassing audio experience. You may want a quiet space inside the vehicle. And that brings in technologies such as adaptive noise cancellation, or more specifically road noise cancellation, just creating that quiet environment with which to enjoy other experiences. Safety will always be a factor. So again, I think we've heard a lot of that today. Everybody has talked about the safety implications of their technology. And this is becoming extremely relevant inside the cabin as well. Not something you would immediately think of, but the simple things such as warning chimes now have to be done in a functionally safe environment. So even functional safety is an important element of the cabin experience now. And the last one here is something that I actually believe quite passionately about, which is this personalized experience. I think we're all accustomed to getting into a car, sitting in the driver's seat. If it's a new vehicle, maybe you're borrowing it, or it's a rental car, and you spend the next 5 or 10 minutes adjusting all the controls, changing the seat, changing the mirrors, etc. If you actually think about the technology we have in a car, that's kind of ludicrous. Why do we have to get in there and control the car in order to personalize it? Why doesn't the car just recognize me? Hi, Andy. and adjust everything. We've got all the sensors and actuators to do that, but that, to me, is a significant part of the user experience. Just think of the car adapting to you rather than you controlling the vehicle. And I think that's very much a direction that we're moving in here. Okay, so maybe just getting a little bit more technical here. So we've talked about the customer needs and the expectations. So let's talk a little bit about some of the technical challenges and opportunities. So on the left-hand side here, you see some of the applications that I've talked about. You know, could be L2 to L4 ADAS. Something, again, I'd like to expand upon a little bit later is the actual user interface to the vehicle, which today is primarily through knobs and switches and touchscreens. My own personal opinion is we're going to get very used to talking to our car. I think that's going to be a significant shift in the user experience. And then I also mentioned immersive audio and things like road noise cancellation, other sort of acoustic technologies in the vehicle. On the right-hand side, you see the results of a study as to what this means for some of the system elements. All these new applications have to be supported by hardware and software. And what we found was, first of all, there's going to be about a 10x, at least a 10x increase in the data traffic flowing through a vehicle in the cabin, just in the cabin. What we also found is a lot of these system elements, such as cameras and displays, will grow by about a 3x factor over the next 5 years, just in one generation of vehicles. Other things such as microphones and audio processing, similar sort of change. Again, we would anticipate at least a doubling, if not 3 times the amount of these elements being in the vehicle. So the bottom line here is we're going to see a dramatic increase, almost an explosion in some of the system elements over this time period. So we have a couple of choices. We can just scale the existing architectures. You know, we've got 3 times more displays, so we'll add a lot more wiring, add a lot more complexity to the vehicle. But I don't think that's a good solution. That will lead to excessive cost, that will lead to excessive weight, and basically a system integration complexity that will just become unmanageable. So again, I think this is going to happen. The question is, how do we do this in a realistic manner? So just as another example of the challenge, I talked a little bit about the overall data throughput. So I want to talk here a little bit about just the processing implications. And this is just another example with audio. So on the very bottom of the chart on the left, you see just standard audio functions. Today, standard audio functions consume about 1,000 MIPS of a DSP or an integrated processing in an SoC. All the other blue things, the light blue things here, are all new applications that we're seeing being developed in vehicles. So we're seeing things from sound synthesis, electric vehicle warning sounds, noise cancellations, new advancements in 3D audio from Dolby, etc. These are really driving an explosive need. And again, this is just the infotainment processing. So this is a study that Analog Devices has done based on real customer applications and requirements. We've obscured names to protect the innocent here. But what you see effectively is we go from that baseline of 1,000 MIPS, and you see how it progresses over time. And again, these are real-life examples. So we go from that 1,000 MIPS of the basic function to over 7,000 MIPS of processing power required in the next generation of systems that will be deployed in 2027, 2028. And just kind of averaging this, what you see is about a 3 times increase in the amount of processing that's going to be required in this one generation, just over the next 5 years. And of course, you see the shape of the curve. It's not plateauing. It's getting exponentially larger over time. So we've got to prepare for this. This is another real challenge. So I've talked a lot about the challenges. Let's talk about some of the system or some of the solutions that we need to bring to bear. So first of all, there's a new architecture required. This is a very simple diagram of a zonal-based architecture, but I think it's pretty clear for all the reasons that you've heard about earlier today, that this is the direction that we have to move in. Second part of it is we need to really be bringing system-level solutions to bear. So this is not about one technology, it's not about an improvement in one system area. It's really about bringing complete systems, a complete systems approach to realize all the new applications that I talked about. So the first one is just in the user interface itself. I alluded to this earlier. I think this is going to be really important. If you have sat in that rental car that I talked about earlier and tried to figure out how to enable Bluetooth or just, change a simple parameter, you've probably gone through 5 layers on a touchscreen, which is really getting very unmanageable. So our vision is that voice processing will transition from being just an infotainment feature, where you say, please take me to the nearest gas station, to actually being used to control even essential vehicles, essential functions in the vehicle. So this is one. The next thing is just everything that I talked about in terms of application space, even though it's in infotainment applications, they all have a real-time element. If we're talking about, a camera system, a driver monitoring camera system, or a microphone, things that, again, are part of the infotainment system, require this real-time determinism and scalability. So this is another element of the system. Power management, again, talked a lot about that today in terms of electric vehicles. It really is becoming a primary parameter. Some of these processors used in the infotainment systems are now consuming over 100 watts, a very significant part of the equation here. And then on the left-hand side, you see some examples of the connectivity technology. So this architectural shift towards zonal is not just about distribution of processing. It's not about centralized processing and zonal ECUs. They have to be connected. And the connectivity technology here is quite unique to automotive. So again, just a couple of examples here. The first one is connecting to the displays. ADI has a gigabit multimedia serial link. It's a SerDes technology that is required to do very high-speed transmission to displays. Ethernet is becoming a dominant technology in the vehicle, but only in connecting ECUs or only in the domain. We see a need to go all the way to the edge, take Ethernet to the edge, and there are standards associated with this and real solutions that are now being introduced to at least offer alternatives to CAN bus and LIN bus, FlexRay, etc. With Ethernet going from edge to edge, we can get rid of a lot of those inefficient, or at least cost-inefficient gateway functions just translating from one protocol to another. Similarly for audio, again, you wouldn't think of audio as being a function that necessarily was associated with a high-performance connectivity technology, but it has to be once you introduce microphones into the system, and you have to deal with wide bandwidth noise cancellation, such as in road noise cancellation, you require that real-time deterministic technology. So you put all this together, and really it's our view that we have to include technologies like this in a system solution to simplify architectures, make it really easy to deployment. We've really got to cut through the complexity associated with introducing some of these new technologies on a fast pace, and really enable that real-time, low latency ability inside the vehicle at the edge. So I've talked a lot about wired technology. The other thing I wanted to just spike out here is the role of 5G. We've had wireless technologies inside the vehicle for quite some time, but with 5G, we finally get a high bandwidth, low latency connection to the cloud, effectively. So the vision, again, of V2V or V2X, I think will finally be realized with 5G, enabling cloud services, enabling over-the-air updates. This is the technology behind this, the software-defined vehicle, effectively. Introducing that personalization. When you walk in there, you have your cell phone, it recognizes you, all the parameters get downloaded, it's now your vehicle. This is really the vision that we have here for 5G. So, kind of summing it up here, just looking at what it's going to take to realize this vision. First of all, you know, the diagram on the left-hand side of a domain architecture is simply not scalable. So there has to be a change in architecture here. If we're saying on the top end, there's about 20 gigabits per second flowing around the vehicle today, that's going to be 200 gigabits per second over the next 4 to 5 years. So we have to move towards these zonal architectures. And we believe strongly that there has to be specific technologies for automotive to realize this vision. From our Shark DSPs on the left-hand side, through some new algorithms and software that are being developed, to the specific automotive connectivity technologies that I highlighted earlier. So, just wrapping up here, I'll wrap up with how I started, with basically saying we have challenges. But with the challenges, we have opportunity. And I think one of the reasons why we're here today and why we're at Electronica is to work together to make this happen. Thank you very much for your time.